Assalamualaikum and hi, we are from the group The Florists. Will be representing our group project for MAT123. I will introduce you to all my group members. Firstly, our group leader Nurujana binti Zarudin. Secondly, me, Nur Afifah binti Ahmad Tanizi. The third one is Nuratika binti Zainuddin. And last but not least is Wan Fatih Humaira binti Wan Mahadin.
I would like to explain about the stool. A stool is one of the earliest forms of seat furniture. It bears many similarities to a chair. It consists of a single seat for one person without back or armrest. On a base of a stool, there are either 1, 2, 3 or 4 legs. A stool is generally distinguished from chairs by their leg of arms and a back. These various stools are referred to by some people as backless chairs. The origins of stools are lost in time, although they are known to be one of the earliest forms of wooden furniture. The dysphros was a 4-legged stool in ancient Greece, available in both fixed and folding versions. In the medieval period, seating consists of bench, stools, and the very rare examples of throne-like chairs as an indication of status. These stools were of two forms, the bench or Gothic stool, a short bench with two bird-like feet off the ends, and also the simple turnstool. Later developments in the 17th century produced the joint stool, using the developing technique of joinery to produce a larger box-like stool from the minimum of timber by joining long thin spindles and rails together at right angles.
This is the application and shape involved for dressing stool. Various shapes and designs are available in this dressing stool. Among them are square, round and others. As we can see in the picture, we have a round dressing stool. The shape that was involved in round dressing stool is a cylinder shape. It was used every time you want to put on makeup, wear a skincare, wear a hijab and others. There is also a round dressing stool that can open its cover. We can store things like wet tissue and others in it. Round dressing stool also has a variety of design and color. That's all for the application and shape that was involved in dressing stool.
Next, I'm going to present about the mathematical calculations for both of our cases. Our first case is round dressing stool. As we can see here, this shape is so much related with cylinder geometry shape, where we can describe it like this. Let's start with the mathematical calculation to find the surface area of the cylinder. As shown in this slide, there's the formula which is 2 pi r squared plus 2 pi r h. It's given that the radius of the cylinder is 4 cm and the height is 7 cm. By using that formula, just insert all the information given in the formula. This is how the calculation would be. 2 pi, which is 22/7 multiplied with 4 squared, plus 2 multiplied by 22/7 multiplied by 4 and multiplied by 7. Calculate it all and you will get 276,5,747 squared as the final answer. Now we will find the volume of this cylinder shape. The formula is B times H. Be considered as base. By using the same measurements as just now, put those information in the formula. Because of the base of the cylinder is a round shape, we will use pi r squared to find the base. The formula can be pi r squared times h. So 22/7 multiplied by 4 squared times 7, we will get 353 cm3 as the volume of the cylinder.
Before we move to the next case, these are references that we use in our project for our first cases, which is round dressing stall.
I would like to explain about the history of Petronas Twin Tower. Petronas Twin Tower is designed by Argentine-American architect Cesar Pani. The 88-floor towers are constructed largely of reinforced concrete with a steel and glass facade designed to resemble motifs found in Islamic art, a reflection of Malaysia's Muslim religion. Planning on the Petronas Tower started on 1 January 1992 and included rigorous tests and simulations of wind and structural loads on the design. Next, excavation works began on 1 March 1993. The construction of the superstructure commenced on 1 April 1994. The spires of Tower 1 and Tower 2 were complete on 1 March 1996. The first batch of Petronas personnel moved into the building on 1 January 1997. Moreover, the building was officially opened by the Prime Minister of Malaysia, Tun Dr. Mahathir bin Mohamad, on 31 August 1999. Petronas Twin Towers were the tallest buildings in the world from 1998 to 2004 when they were surpassed by Taipei 101.
This is the application and shape involved in Petronas Twin Tower. First, let's take a look at the base of the building. The design of each tower floor plate is based on simple Islamic geometric form of two interlocking squares, creating a shape of an 8-pointed star. There are two squares that are interlocking of each other and a small circle in the middle, as you can see in the picture 1. Then, a huge octagon shape and circle are drawn outside of the previous shape and at the corner of the square. However, the tower has limited floor space, so the architect adds semicircle to each of the inner angle as you can see at the picture 3 and 4. This design represents unity, harmony, stability, and rationality in the Islamic culture. Secondly, there are 4 cylindrical buildings from Petronas Twin Tower. As you can see from the picture, there are 2 small cylindrical buildings that are attached at each of big cylindrical building. At the upper part of the building also has a cone shape that are attached to the cylindrical building. Next, the Petronas Twin Tower bridge that are known as sky bridge are actually cuboid shape. It was attached to each building to provide some structural support to the towers during high wind. Lastly, at the top of the building, there is a small pinnacle. That's all the application and shape involved in Petronas Twin Tower.
Move to our next case, which is Petronas Twin Towers. It might be a little bit confusing by the missing shapes used. This is what we can turn it into. As we can see, it consists of triple C, which is cylinder, cone, and cuboid. To find the surface area, these are the formula for each geometry. Since we already touched about cylinder just now, I'll talk about cuboid and cone. For cuboid, this is how we should imagine its plan. There are 2 fronts, which is front and back, 2 top and bottom, and 2 sides. So the formula is 2 in brackets, front plus top plus sides. For cone, S is a cylinder of cone. The formula of cone is S pi r plus pi r squared. I'll show you one by one calculation to find surface area. Firstly is a cylinder. There are 3 stages of cylinder shape: small, medium, and large one. This is the formula that we used just now. So let's give the examples for each measurement like this. By using the formula, insert all the information given and you will get this. The smallest cylinder is 62.8572 cm squared. The medium one is 150.8571 cm squared, and the largest cylinder is 312 22,8,571 cm². For cupid and coin, there is their surface area formula. The measurements are given in the slide, and as usual, put those information in each of the formula. In the end, you will get those as the answer. The surface area for cupid is 46 cm², while the coin is 37,7,143 cm². After you did the steps one by one, you need to add all the answers back. Since there are two sets of cylinders, left and right, and two coins, add all in one bracket and times with 2. Then plus with cupid surface area. Calculate it all and you will get your final surface area answer for the Petronas twin towers, which is 1,202.5,740 cm². Last topic for mathematical calculation, which is to find the area for Petronas twin towers using the same geometry shape as before. Those are the formula for our triple TC. Start with the 3 stages of cylinder. The formula to find volume of cylinder is given in this slide. The information in each cylinder follows in the slide are ready for you to calculate. Put the radius and height measurements in the formula and you will get the answer like that. The volume for the smallest cylinder is 113.1429 cm3. The medium size is 707.1429 cm3, and the largest cylinder is 4073.1429 cm3. Next is to find the volume of both cupid and coin. Look at the formula shown there. For cupid, its mean length times width times height, while coin formula 1/3 times pi times r squared times h. Measurements are given same as when we find the surface area. Write it all in their respective formula and you will get their own volume answer. For coin, to find its height you need to use joint Pythagoras and then continue to solve it as usual. Last but not least, the total volume for the whole Petronas twin towers geometry are adding up as shown in the slide. Same as total surface area before, you need to times with 2 for cylinders and cones volume and plus with cuboid volume. The final answer you will get 9829.8898 cm3.
Before we move to the conclusion, this is our reference that we use for Petronas twin tower to complete our project. From this project, we can conclude that geometry is important in our daily life. Why is it important? It is because we can find huge application in the real world as they help us in deciding which material to use with design to make and even play a vital role in the construction process itself. For example, buildings are built in different type of shape to give a new look and show the uniqueness of the building. In our project, we choose Petronas twin tower and non-dancing stall as our cases. We learned about the application involved in these cases as my teammate Nuratika explained it before. We also get to learn the history and general information about our cases as Wan Fatin Umaira explained it in the first video. In this project, we get to use the formula that we learned in MAT123 to apply in the mathematical conclusion as Nurjana showed the conclusion how to get the surface area and the volume for the building. We also gain more knowledge about geometry through this project and got to know that geometry is involved in our daily life. We hope you can enjoy and understand this video to gain more knowledge. That's all from us, the Florets. Thank you and bye!